Hey folks, we are moving on to circles. So we're going to learn how to find the area and the circumference, which is essentially the perimeter of a circle, but we call it circumference since it's round. Here are some applications of what these would look like in the real life. In certain parts of the countries, their fields are circular, so they'll find the area of those fields, or you see here we have like a radar from maybe an airplane or something, and then over here we have a map. In a lot of criminal cases, they use circles in their areas to find, maybe where a crime happened or where the criminal could be in this radius of the circle and so on. So those are just some applications of when you could see this in real life. But we're just going to talk about the parts of a circle here, okay? So I'm just going to abbreviate what are in these paragraphs by labeling this circle in our picture. So let's start with the basics. P right here is the center of the circle. And that's how we name a circle. So I would call this circle, circle P. So it's a circle with a dot and then the center. So circle P. Then if I have a line that starts at one point on my circle and goes through the center and ends up on the other side, that's a diameter. So a diameter goes all the way through the center of a circle. A radius starts at one point and then stops at the center, so it's only half. So that's a radius. And the last thing we have here, angle APC. So this angle right there, we would call that a central angle. And that goes, has its endpoints on the outside and its vertex at the center. So that's a central angle. Some more parts of a circle here we call arcs, and we have different kinds of arcs. We have a major and a minor arc. Now how you differentiate them is a minor arc is smaller than a semicircle, and a semicircle is half a circle, okay? So let's look here. RS is blank. Well, do we see that it's not quite full a half circle? So this would be a minor arc, think it's smaller. And then it says arc STR, so STR. Can we all agree that that's greater than a half a circle? This would be a major arc. Now another way to tell is a minor arc, you only use the two endpoints to name, so that's how we got RS, arc RS. Whereas a major arc, you use its two endpoints and then a point in between them, so that's how it's arc RST. So we have a major and a minor arc. Now let's practice doing some of those on our own. So it says, what are the minor arcs of circle O? So again, minor arc is less than a semicircle. So here we are. AD would be one. And then we would have DE is another one. CE. Do AC. And that about ends it for us. Okay, what are some semicircles of circle O? Remember that's half a circle, so I have one from D to C. And then I have another one from A to E. And lastly, what are the major arcs of circle O? Remember, these are greater or bigger than a semicircle. So let's see here. If I start at A and come all the way around, well, here's a semicircle, so I have to go further than that. I could have arc A, pick a point in between, so I'm going to pick D, then C, ADC. Then I could have another one. What if I started at E and worked my way around here? There's a semicircle. And continued to C. So that would be arc E, D, C. Let's start one more time. What if I started at D, went around, there's a semicircle, and stopped at E? So arc D, A, E. So those are just some examples of a major arc. Now we're going to learn how to find the measure of these arcs, and it's actually quite simple. So how you find the measure of an arc is that it corresponds to the central angle. So if I wanted to find the measure of arc RT, it corresponds to this angle that it's formed by. So you guys see how I have angle RST at 50 degrees? So that means my measure of arc RT is 50 degrees. Next part here, find the measure of arc TQR. So that's this major arc. Well, how can I find that? Well, if I know that this angle right here is 50, what's left of 360 for this angle here? So 360 minus 50, 310. So the measure of major arc TQR is 310 degrees. Now again, let's practice doing some of these arcs on our own here. So what is the measure of each arc in circle O? BC. Here's BC. Again, it corresponds to this angle there. And if that's 32 degrees, then my arc is 32 degrees. Find the arc measure of BD. So now I know that this is 58, and we just found that this was 32. So can I just simply add those two together to get the whole thing? So 58 plus 32 equals 90. What about major arc ABC? A, B to C. Well, isn't that just a semicircle? So what's half of 360? 180. Nice job. Now lastly, angle major arc BAD. This big guy over here. So again, we found that arc BD was 90, so can I just subtract 90 from 360? 360 minus 90 equals 270 degrees. So again, just remember that the arc measure corresponds to the angle, its central angle. Okay, now we're going to learn how to find the perimeter or the circumference of a circle. Again, that's the distance all the way around the circle. So the formula for that is circumference equals 2 pi r, or circumference equals pi d. And the reason for that is because I can fit 2 radii into one diameter. So that's why both of them work, okay? And a way you can remember this is twinkle, twinkle, little star, circumference is 2 pi r. That is a quick little way to remember the formula for the circumference of a circle. So let's try a few of these. Find the circumference of each circle. Leave your answers in terms of pi. Remember, pi is just a number, a specific number, 3.14, and it goes on forever. Also a key on your calculator. So let's start here. Since I'm given the diameter of this circle, I'm going to use the second formula. So circumference equals pi d. My diameter is 8. So pi 8. Pi times 8. But the correct way to really write that would be 8 pi. So you always put your numbers first. So equals 8 pi centimeters. move on to the next one here. I'm given a radius, so I'm now going to use 2 pi r. So 2 pi r. My radius is 3.3. So now I'm going to take my numbers times each other, so I'm just simplifying. So what's 2 times 3.3? And I get 6.6 pi. And I'm in inches. Now this time, we're working backwards. So it says, what is the radius of circle A if my circumference is 24 pi meters? So again, this is my formula for circumference, 2 pi r. And this time I know what it equals. It equals 24 pi. So I'm going to put that in for C. So now I know 24 pi equals 2 pi r. And our goal is to figure out what r is. So I have to get r by itself. So this is just straight multiplication, guys. All this means is 2 times pi times r. So how do you undo multiplication? You divide. So I'm first going to divide by 2. Divide by 2. Those go away. 24 divided by 2 is 12. Okay, remember, pi is just a really special number, so how can I get rid of multiply by pi? Divide by pi. Divide by pi. Divide by pi. That goes away, this goes away. So now I'm just left with 12 equals r, which is my radius. So 12 meters. Okay, we are going to skip the next page for doing these together in class. So skip the car one and skip this arc one. Now we're going to go to area of a circle. So the area of a circle is the product of pi times the radius squared. So area equals pi r squared. And the way you can remember that is apple pie really rocks, because r times r is r squared. Okay, so let's try an application of finding the area of a circle. It says, what is the area of the circular field at the right? Give your answer in terms of pi and as a decimal to the nearest 10. So, in our picture here, they're telling us that our radius is a 1/4 mile. So I know my formula equals pi r squared. Can I just plug in a 1/4 mile in for my r? How else can I write a 1/4 mile as a decimal, since I know you guys hate fractions? 1/4 equals 0.25 as a decimal. So I'm going to write it as that. So pi times 0.25 squared. Okay, what's 0.25 squared? 0.625. So again, we usually write the number first. So I'm going to write equals 0.625 pi miles squared. Or, since it wants it as a decimal, I'm going to take 0.625 times pi and get approximately, it's an approximation, 0.1963 miles squared. That is the area of this field here found in Saudi Arabia. It says this is irrigated, fed by wells pumping fossil water from an aquifer. That's exciting. Why would we want to know the area of this? Well, we could figure out, well, how much water would I need to water this field? So, figure out how much water we need. Or you could see what your field would yield, like how much money would you make off this field, or your profit of that field. typo, i.e. Excuse me. There we go. Perfect. Okay, and then our last question for this video lesson here. So this time we are given the circumference of a circle is 12 pi. What is the area? So this is kind of a twofer. First I gotta think circumference is twinkle twinkle little star. Circumference is 2 pi r. So I'm gonna write that down. Now I'm gonna plug in what I know. Because our goal is to find the area. And we know the area is pi r squared. So I essentially need to use the circumference to figure out what r is, and then plug it into this equation there to find the area. Okay? So first we need to find r. So if my circumference equals 12 pi, I can work backwards now to get r. Again, these are just numbers, and you're just multiplying, so I can divide. So divide by 2 pi, divide by 2 pi. These cancel. 12 divided by 2 is 6. Pi divided by pi cancels out. So we just found our radius to be 6. So now, do we have enough information to find my area? Well, sure we do. We just found our radius to be 6. Now we're going to plug it in. Area equals pi 6 squared. 6 squared, everyone, is 36 pi. So we can leave it either as 36 pi inches squared, but if we wanted to approximate what's 36 times pi, we get approximately 113.09 inches squared. Alright guys, thank you for watching. We will finish this lesson up next time in class. Have a good rest of your day.